right, 10.2. We have vectors in space. So same things that we did with vectors before, we're going to do again, but now it's just three-dimensional. So we have x, y, and z are here. Since it's vectors, it'll be v1, v2, v3. So we have our 0 vector, which is just 0, 0, 0. Remember, we can have a vector written in vector notation, which is with the I, j, and k. We can also have it in component form. So if I had a vector that was, let's say, 5i minus 3j plus 4k, what would this be in component form? Awesome. 5, negative 3, 4. So before we just had I and j, now we have I, j, k. Yes. We can be given 2 points, an initial and a terminal, and be asked to find component form. So remember, just like before, it'll be terminal minus initial. And then down here, we have the magnitude. So instead of just squaring the first number plus squaring the second and taking the square root, we now have to add the third number squared. So same thing, we just have that third term in there. A unit vector in the direction of v, we would just take vector v and divide it by the magnitude. And then we can perform operations with vectors just like before. We can add them together. So the first gets added to the first, second gets added to the second, third gets added to the third. We have a scalar multiple, so you just distribute that. And then the dot product is the first times the first, plus the second times the second, plus the third times the third. So it's pretty much the same formulas as before. So example 1. We have to find the component form and magnitude of vector v having initial point 3, 4, 2 and terminal point 3, 6, 4. So our component form is what? How do we find the component form?
What's the formula?
That's what I'm asking you.
I don't know. Okay. No, I don't know.
Terminal minus initial. So we start with our terminal point, which is 3, 6, 4. And then our initial point is 3, 4, 2. And we just subtract. Oh, these are points, so they should have parentheses. It tells you the initial point is, the terminal point is. Just got to read. So it'll be 3 minus 3, which is 0. 6 minus 4, 2. And 4 minus 2, 2. So this is our vector in component form. Next, we can find the magnitude of this vector. We're calling it vector v. So the magnitude of v, how do we find the magnitude? Yep. So we square the first term plus the second term squared plus the third term squared. And then just take the square root of all of that. So this will be 0 plus 4 plus 4. So the square root of 8, which we can simplify to what?
2 square root 2.
Awesome, 2 square root 2. And then to find the unit vector, there's a formula for that too on the last page. You just take vector v and divide it by the magnitude of v. So Just leave it as the radical if you can't simplify. So vector v would be 0, 2, 2, and then we're dividing that by our magnitude, which is 2 square root 2, 2 square root 2, 2 square root 2.
How do you even divide that? Oh.
What's 0 divided by 2 square root 2?
You're doing them all separately.
Well, because there are 3 different ones. What's 0 divided by 2 square root 2? 0. Next I have 2 divided by 2 square root 2. So the 2's cancel.
So it's just. Oh wait, you get the radical to the bottom. I don't even remember what we got though.
Alright, so that's why we're doing this, so we can remember, in case this is on our final. So we get 1 over square root 2, and then the other one's going to be 1 over square root 2. But we have to rationalize. 0 stays. How do I rationalize this to not have the square root on the bottom? Multiply the top and the bottom by square root 2. So what do we get? Square root 2 over 2 and square root 2 over 2. So this is our unit vector. We have to find the dot product of our two vectors. How do we find the dot product? So we multiply the first times the first. So 4 times -1 would be -4, plus the second times the second, 0 times 3, 0, plus the third times the third, 2. So -4 plus 0 plus 2 is -2. Right. The angle between two vectors, our formula is the same exact thing that we had when we just had 2 terms in 2-dimensional. So we're going to skip that because we've already done it, and it'll be on your final, so you guys already remember. Well, you just find the dot product, plug it in, and then find the magnitude of u, the magnitude of v, plug it in. You just plug it in, then take the cosine of that, so you'd have to do the inverse cosine.
Wait, do we have to know this for the quiz?
Not for the quiz. That's why we're skipping.
Cosine -1.
Yeah,
Is this on the review?
this is on the review, yes. The angle.
Cosine -1.
Because when we do this, we'll get some type of decimal, so it'll be cosine theta is equal to, let's just say, 1.24 or something, whatever. Then to find what actual theta is, remember you have to do the cosine -1 of that number. And that gives you theta. So for example 3, are the vectors orthogonal? Do we remember what it means to be orthogonal? Awesome, when you take the dot product and it equals 0. So we want u dot v to be equal to 0. What does it mean to be orthogonal? That's off. Yeah.
Does that mean it's like a center?
It's when the vectors meet at 90 degrees. So orthogonal is the same as perpendicular. So we want to take the dot product of u and v. So how do I find the dot product? First times the first, plus the second times the second, plus the third times the third. So it's 3. So are these vectors orthogonal? Nope. Because they parallel. But if two vectors are parallel, then they are proportional.
What does that mean?
You would just set up like the first over the first over the second. Like for the first point, it would be like the first number in u over the first number in v, then the second number in u, second number in v, and just the proportions have to be the same. All right, any questions here? All right, we have a couple more. So we have u, v, and w. So it just asks us to perform the operation. So we have to add u plus v, u plus w minus v. So first thing I want to do is add u and w. So u is 1, 0, 2, plus w, which is negative 4, 7, 10.
You just add like the first and the third and then-
Yep, just add the first and the first, we get negative 3. Second and the second, we get 7. And third, we get 12. And then minus v. V is 3, 1, 0. So first minus the first would be negative 6. Second minus the second, 6. Third minus the third, 12. Awesome. Right, in 2, we're doing the same things, but we're multiplying by a scalar, so we have to do that first. So I have 3 times vector v, which is 3, 1, 0, plus 2 times vector u, which is 1, 0, 2, minus 6 times vector w, which is, because it's just 3 instead of 2. It's the same. So this would be 9, 3, 0, 2, 0, 4. So we could either distribute the negative 6 and make it a plus, or distribute just 6 and keep it minus. It doesn't matter. We could do it either way. If I distributed negative 6, this would be positive 24. Negative 6 times 7 is negative 42. And negative 6 times 10, negative 60. So we can add all 3 at once. So 9 plus 2 plus 24 is 35. Then I have 3 plus 0 plus negative 42, negative 39. Then I have 0 plus 4 minus 60, negative 56. And that's our vector. All right, we have one more. So here I have to find the dot product of u and v. So it's written in not component form. So how do I put this in component form? 1, negative 6, 3. And what would v be in component form? I is your first one, j is the second, k is the third.
I know, but you just like,
The coefficients, that's it.
I know, but you don't like.
No. So what would vector v be? Awesome, 5, 0, 2. Because we don't have a j, so the middle number is 0.
The order is always
IJK, just like the alphabet. So we're taking the dot product between these two vectors. How do I find the dot product? So first times the first, plus second times the second, plus third times the third. 11.